In this video, I will show you that in a couple of hours, you can have a working embedded Linux distribution built and run it on your device. Here, I built for Beagleboneblack and qemuarm. I refer to Yocto project documentation for the required information. So in order to build, we need a build host. A compatible Linux distributions would be good enough. Some of the requirements are: it needs 50 GB of free disk space. It runs a supported Linux distribution. So I use Ubuntu 22.04.1 LTS. The required software versions are Git, tar, Python, GCC and GNU Make. So if you use the latest GNU distribution, ideally you have all of this. If not, you can install them separately. So build host is the system used to build images on Yocto project development environment. So that is your build host, and the target is the board that you're building for. Well, build host packages. So the first we need to install the host packages on the build host. So these are the required softwares that we need. So let's install all of this. So as you can see, some of the packages are already installed for me, and the ones that are not installed will be installed now. Now the packages are installed. I'll clear the screen. After we install the build host packages, now we need to clone Pokey. Pokey is the reference Yocto distribution. This is basically used to build the Yocto project. Let's clone the Pokey now. So using git clone command. Then let's move to the Pokey directory. We can see all of the branches that this repository has. You can see there are a lot of branches, but what we're interested is in the Beaglebone. So this is the release that we're going to use. So let's check out that release branch. So the command is the git checkout -t origin Beaglebone and -b my Beaglebone. So basically what it does is -b, it will create a local branch for me with the name my Beaglebone. So if I see the git branch, you can see that it is under my Beaglebone branch. Now let's start building the image. The build process creates an entire Linux distribution including the toolchain from source. Use following steps to build your image. Initialize the build environment. So run OE means it's open embedded, init to build environment. Set up script to define Yocto project's build environment on your build host. You need to be within Pokey directory. So now we are under Pokey directory. So I will use this command source OE init build environment to initialize the environment. Okay, so now what we see is that the script creates the build directory. Once the script is run, when you run, your current directory is the build directory. After the build completes, all files created during the build will be present in this directory. So now with this, we have moved from Pokey directory to the build directory, and this has become our current working directory, present working directory. And you can see that it actually creates a file called local.conf file. Okay, so now let's examine and update our local configuration file. So for this example, the defaults are set to build for Beagleboneblack and qemuarm. So what we will do is, let's edit this vim conf and the local conf. So this is the file. I press I to insert, go to edit mode, and then here you can see that it already supports qemuarm, or these are the machines that it supports, qemuarm. So I will enable this because I can run qemuarm to basically check in the computer or as an emulator without flashing into the board. These are the QEMU versions, and the hardwares that it supports are Beaglebone Yocto and the generic x86 and generic x86-64 and Edge router. So these are the machines that it already supports. So what we're building is for Beagleboneblack. So I just enable this, and this one I will comment it because I will not run the QEMU x86-64, so that I just want to be aligned with Beaglebone and the qemuarm, as Beaglebone is an ARM architecture. Now I will write and quit, that means save. The next step is start the build. The build an OS image for the target with the following command. So bitbake core image minimal. So it builds a minimal core image, and one flag that you can use is -k. In case the bitbake finds any errors during the build, without -k it will abruptly stop the build. With the -k, what it does is, even if there is any stage or any step that is failed, so it will continue the build until wherever it is possible. So it is something like, even though some particular step is failed, it will try to continue until where that dependency is not met. So I will start the build now. Depending on the resource availability, the number of cores that you have, the memory, it will take time. You can see the build configuration. The BB version is 2.0.0. The build system is x86-64 Linux. This is the build system, that means the host. Native LSB string is Ubuntu 22.04. That's the host that I'm using. The target sys is the ARM Pokey Linux GNU ABI. This is the target system. The machine is QEMU. The distro is Pokey. Distro version is 4.0.6. This is the version of Pokey that we're using. That's the Yocto project is the Kickstone. And the tune feature is ARM. We PF, the Cortex A50, Neon. It supports thumb instructions. The call convention is hard. So the Meta Yocto BSP is my Kickstone, and this is the version of the Git repository that we're using. Git commit version, I would say. So it will take some amount of time based on the performance of your PC. So I will explain in the future what are the steps that it goes through, what is Pokey, and the internals of Yocto project. So that is the topics for the next videos, the coming videos. So for now, let's wait until the build is finished and then we'll come back. Now the build is done. So it took quite a while. So to me it took around 9 hours or so. So well, now we are ready to test the image that we have built. To simulate our image using QEMU, we just have to run QEMU and qemuarm. So this is the command that we have to run. And make sure that you're actually within the environment that is under dev Yocto Pokey the build, and the build environment is set. And now you can see that I launched the command. So it asks for a sudo, means the password, which we enter now. Well, the guest has not initialized the display yet, so it will come. So this is the QEMU window that we get. Well, you can see that the Linux image is booting. Of course, please wait, it's booting the starting version 3.2.10. So it just startup log, or the kernel log, I would say. And here normally any Yocto build, normally just by entering normally the login would be the root, and you will have a root. You will log in as a root user. So I'll just check the uname -a, and you can see that the information that it gives is Linux qemuarm 5.15.78, the Yocto standard. This is the kernel that we're using, and the one SMP preempt, and Wednesday November 16. So this is like the November 16, 2020. This is when the Pokey, I think this image was built. Oh, sorry, this image was referencing to. Well, now I will try to do something. ls. Okay, I'll come back to the root directory, and ls, you can see it has the bin dev home, whatever the last, plus found mnt run sys user. This is the file system that it has. So this is pretty much in QEMU, where you can witness here that the Linux image that we have built is running. So you can directly close this here. Okay, so now that we exit the QEMU, the next thing is we will try the built image with the Beagleboneblack and run it. So as you can see, maybe I will show you. this is the Pokey. Yocto Pokey, and then here you will see the build. This is the directory where the build happened, and in the temp, if you go to the deploy, this is where the images are, image and qemuarm. Okay, now I realize that it's just built for qemuarm and not for Beagleboneblack. Then I'll have to keep it for build for Beagleboneblack. So well, for that what we need to do is vim the configuration and the local conf. We'll have to edit it. So if I understand, we can just build only one type of or one kind of machine at once. So now we have built for qemuarm. I'll comment it, and now it will build for Beagleboneblack. Escape, write and quit. So that means we're going to save it. Okay, so then now we'll have to issue the same command, bitbake -k core image minimal, and let's see, it will start the build. And the important thing that we need to note here is, for the successive builds, it will not take so much of time. So first time it took 9 hours, so now it may not take so much time because there are some, like pretty much lot of files or the packages that you can reuse. So that's the advantage of the Yocto project. Well, I will come back, or let's come back once the build is done, and I will show you how do we flash it, or how do we transfer this image to Beagleboneblack and run a few commands there to see what we have built works or not. Well, here you can see that the build version is the same, 2.0.0. The build sys is similar to qemu what we have used. The only difference would be the target sys, the ARM Yocto Linux GNUEABI, and the machine is the Beaglebone Yocto. The distribution is Pokey. Distro version is 4.0.6. As I told, this is the Keystone release. And the tune feature is ARM VFP Cortex A8. This is the architecture of the Beagleboneblack or the Beaglebone hardware. Neon is the hardware floating point unit, and I think call convention is hard. So this is the information that we can get it here. So the build is happening, so it will take some time. Let's come back when it is finished. Well, now that the build is done, so it took almost 4 hours for me to build Beagleboneblack after qemuarm. So let's find out where the binaries are, the images. So as you can see, we are under build, temp and deploy. The images, so first we had the qemuarm. Now after building for Beaglebone, we have Beaglebone Yocto. And here it has a lot of files like DTBs, the device tree related stuff. And then you have the core image that are and then what we are interested is in the core image minimal Beaglebone Yocto WIC. This contains the MLO and the, I mean to say that initial bootloader, actual bootloader, that is U-boot, and the file system. All that is part of this WIC file. So now we know that the images will be under deploy images and Beaglebone Yocto. Let's move to this directory from the command prompt. So change to temp deploy images and Beaglebone Yocto, and you can see that there are a lot of images or files related to images. So as you can see that it is uboot img is a uboot image, and the z image, this is the Linux image. And now we need to transfer this to the Beagleboneblack. For that I have an SD card. So the first thing that we need to do is okay, now I have the SD card here. It's a mass storage device, 8 GB. The first thing that we need to do here is get rid of all the partition that it has. So it has boot and root, which was there, which I had created for my previous build, my previous deployment. So I will stop this and then right click. Here I have minus, and I can use this to delete this partition. Similarly, I will stop this and then delete this partition. So now we have a brand. I can see that the empty SD card now, and then I will close it here. Okay, maybe I'll not close, I'll just minimize to see that if you have flashed them, if you have loaded those images properly into the SD card. Now I use this command dd utility, and the input file is the core image minimal beagleboneblack, beaglebone Yocto WIC. Output folder is dev stb, and bs, the block size is 4 megabytes. So dev stb is where my SD card lies, so that I can check with the lsblk. If you reach the lsblk, you can see that STB is of 7.8 GB, I mean the 8 GB SD card that I had. So I will use this command. Well, it will take some time. Okay, permission denied, and I need to run it as a super user. Enter the password, and here we go. Okay, so it is copied, and if you see the disk space in the 8 GB drive, you can see that the boot partition is created, the root partition is created, and we have the Linux image ready to be flashed into the Beagleboneblack. So what I would be doing is I'll be running the Beagleboneblack with the SD card. So now I will remove or eject this SD card. It can be removed safely. Okay. Here I am inserting the SD card with the image. So I will switch off the board now. The board is switched off, and let's insert the card. Well, now the card is inserted. As you know, we need to hold the switch. Here I am holding this S2 switch to boot with the SD card. After you release, so it will be booted with the SD card. You can see that the board is booting. So what I've done is I've connected via the TTL cable or the TTL to USB cable and accessing the logs. So the login is root, as I had done for qemuarm. Well, now I can see that I'm logged in. I will do an uname -a, which will show us what is the kernel version and the OS that is installed. So here you can see the Linux Beaglebone Yocto is the kernel, and the version is 5.15.54 Yocto standard, and it's a preempt Thursday, July 14. So this is the time when the Poki was referenced. The ARM v7L is the architecture, and the GNU Linux is the OS. So this is how we build and run the Yocto on your Beagleboneblack. Okay, so this is a minimal build. So let's check if it has Python installed. You see the Python is not found, and so GCC, let's see GCC version. GCC is not found. So it's a very minimal system. So what we need to do is, from here we will build a full-blown Linux for our project that I was doing called Sense and Act. For that we need a Linux, embedded Linux for the IoT project. So I will be focusing on building that, also learning or also teaching you about the embedded Linux and Yocto project. So well, that's it for now. Thanks for watching.
If this video helped you in learning, please like the video and subscribe to the channel. Also, share with anyone who is interested to learn more about embedded Linux and Internet of Things. Leave a comment below for any feedback or discussion.